Okay, so this is like take 10 for me. I've had some issues here, but here it comes. It should be a fairly short one, because we're not really going to do very many examples with the formula. We just want to understand where the formula for area of a regular polygon comes from, and so I'm going to work through that with you. We got to start off with some vocab. We've got to know what a regular polygon is. It's a polygon that has all sides and all angles congruent. And you'll notice I typed in the word so you can make sure you can read my handwriting there. So if we're thinking quadrilaterals, a rhombus has all sides congruent, but it does not necessarily have all angles congruent. So only a square would be considered a regular quadrilateral there. Okay. The next word on our list should be the only one in here that is brand new to you, and that's apothum. It kind of sounds like you're saying opossum, but with a lisp. So apothum. Okay, and it's a segment that goes from the center of a figure to the midpoint of a side, and it will always be perpendicular to the side. Okay, so that's an apothum, and we use the little letter A to represent it in our formulas. Okay, radius is the next one, and we know radius from circle as goes from the center to an edge. Well, the circle doesn't have any vertices, so I can go anywhere on there. But in a polygon, our radius is going to go from the center to a vertex. Okay, so both the apothum and the radius come from the center. One goes to a midpoint, one goes to a vertex. All right. And then the last term we have on here is a central angle. And a central angle is formed by two radii, or radiuses. Radii is the proper way to say that. Okay, we're going to come down here below, and we are going to start with the pentagon, which I know is on the right, so it's a little backwards, but it'll be okay. And we're going to start by drawing in all of our radii. Okay, so we're going to pick a point in there that's about the center, and I'm going to draw in all of the radii. Remember, radii goes from the center to a vertex. Now when I do that, I just created 5 different triangles, and I created central angles in here too, that last one. And the thing is that because it's regular, all of these central angles have to be congruent too. So I actually could figure out what each one is, because all the way around is 360, and so 360 divided by 5 is 72. So I'm actually going to go ahead and write that in one of these. It's just good info to have. Okay, so that central angle is 72 degrees because they're all the same. And let's go ahead and label these with R's for radius. Okay, each one of these is a radius. Alright, the next thing we're going to label on our regular pentagon here is an apothum, and I'm going to change colors here so we can see the difference. And the apothum goes from the vertex to a midpoint of a side. Okay? And so it's going to the midpoint. We also know it has to be perpendicular, so I could actually call it a perpendicular bisector. Okay? We're going to label that with an A for apothum. We use little a because big A is for area, little a is for apothum. Okay? So if I'm looking at this, I can clearly see, even though I don't know a formula for a pentagon, and if I look on my formula chart, there's not one. Okay, but I can clearly see triangles, and we know how to find area of triangles. Okay, and so if I wanted to find the area of this triangle, we would need a base and we would need a height. Well, we have a height. The height is the apothum. The base would be what we're going to call S for side. Okay? And so the area of that one little bitty triangle, and I'm going to draw a little triangle right here, would be equal to 1/2 of S times A. That would be my base and my height. Okay? Now, our goal is to get the area of the whole thing, so if I wanted the area of the entire regular polygon, how many of these triangles, I'm going to kind of shade here. Let me just kind of scribble here for a minute. That would give me this area. How many of those do I have? Well, I've got 5. Okay? And I want you to think about that number 5, how it's special here. Well, that's the number of sides. And so what I would do to find the area of the whole thing, okay, I'm not going to put a symbol at the bottom because it's total area. I would take 5 times that 1/2 SA. And we are almost to the formula. If you were to look on your formula chart, what you would find is that the area formula for a regular polygon says this. Area equals 1/2 times A times P. Okay? 1/2 times A times P. And so we've got the 1/2, we've got the A, we're missing the P. Well, what does capital P stand for? We should know that from dealing with our volume and surface area formulas that you did. Capital P stands for perimeter. And so we're taking this 5 and 1/2, excuse me, not the 1/2, this 5 and the S, and we're trading them out for the P. And that's because the perimeter of this figure, since all those sides are the same, that perimeter would just be 5 times the 5, the number of sides. Excuse me, 5 times the length of the side. Okay? So if I were to take out the 5S and say, oh, well, that's just the perimeter, now I have 1/2 and A and P. And that's the formula for a regular polygon. Okay? So let's see it into action over here in our hexagon. I'm going to put some numbers to it right quick. Let's go and let's just say that this side is, I don't know, we'll make it nice and happy. We'll call it 12. Okay? Our formula we're going to use is area equals 1/2 apothem times perimeter. Okay? And so we've got right here, if that's 12, let's figure out what the rest of these things are going to be. Well, we know if we did all of those angles, there'd be 6 of them, right? So 360 divided by 6 means each one of these angles has to be 60 degrees. So I'm going to write in here 60 degrees. Hey, you know what that means? Well, these are the same. So that means they're all 60. The other thing you could have used there, instead of going from the central, is you could use our rule that we learned yesterday, or today, depending on when you're watching this video, that we can find the measures of the interior angles of a regular polygon, and that is that this would have to be 120, okay, and which means that we've got 60 and 60 here that it got cut in half. All right, so any way we look at it, this is actually an equilateral triangle. So let me just go ahead and write in 12 on this bad boy. And this bad boy, and that happens with every hexagon. It makes 6 equilateral triangles in there. Okay. So when I go to find this apothem, that makes it really simple for me here. Okay. Because now we actually have a 30, 60, 90 triangle, huh? So this is actually 6 and 12. So this is x and 2x. That means this apothem here, my A, has to be equal to 6 times the square root of 3. Okay? So my formula uses apothem and perimeter. The only other thing is I need is my perimeter. I can find it now because my side is 12. So the perimeter then would be 12 times 6, which is 72. Okay. So now let's plug it into this formula and find our area there. Formula says 1/2 apothem, which is 6 square roots of 3, times 72, my perimeter. And if you type that all out in your calculator, you're going to find that you get 216 times the square root of 3. That's my area there. And that would be exact. You could always put it in and get a decimal if you wanted a decimal answer. But that would be exact. Okay. All right, let's go down there and see what happens with that triangle right quick. Okay, with the triangle we know we probably don't want to use this formula, right? But I want to prove to you that it works, okay? And so I want to show you what happens here. If I were to draw in my radii, we're going to wind up with, of course, our 3 little triangles there. Now, we know the triangle has 60-degree angles because it's regular. So when I do that, I made 30 degrees here. Okay. So I still actually have a 30, 60, 90 triangle when I drop in my apothem. Okay. So let's just say I'm going to give you the apothem this time. I'm going to be nice and I'm going to tell you your apothem is, let's say it's 4. Okay. So here's another 30, 60, 90 triangle. That apothem is 4. If this is 4, that's my x. That's the short side. That means this is 8. That means this long piece here, and remember, look where I'm looking at here. It's only half of the side. Would be the 4 square roots of 3. So the whole side then has to actually be 8 square roots of 3. Okay. So when I go to find my area, we're going to plug it in and we're going to say it's 1/2 the apothem, which was 4, times the perimeter. Perimeter, if I have 3 of these 8 square roots of 3, that's going to give me 24. 8 times 3 is 24 square roots of 3. Okay. Half of 4 is 2. 2 times 24 gives me 48 square roots of 3. That's my answer. Whoops. Alright, now the circle, I know you're looking at me going, Miss Davila, it says polygons, circles are not polygons. You're right, I get you. Okay, but I just think it's really stinking cool that the same formula actually works for a circle. Of course, we don't call it an apothem. In a circle, we would call it a radius. Okay, so my A is going to actually equal my radius. And in a circle, we don't call it perimeter, we call it circumference, right? Well, circumference is 2 pi r. So if I take those two things and I plug them into that same formula, it works, and I think that's pretty dang awesome. So let me show you that. Area is equal to 1/2 A P. So I'm going to plug in, instead of A, we're going to say R, 1/2 times R. Instead of P, we're going to say 2 pi R. Okay. So the 1/2 and the 2 actually cancel. 1/2 times 2 goes away. Pi is still there. And then we have R times R, which is R squared. So we get that area equals pi r squared. And I think that's really cool. Now, do I expect you to use 1/2 AP with a circle? Absolutely not. I just think it's neat to see the similarities. Just like we talked about the exterior angles, how they all wind up looking like a circle as I get bigger. Well, the formula for that area winds up being the same as a circle as well. So they've got some similarities there. It's pretty cool. All right, don't forget, class tomorrow or Thursday, depending on when I see you, is in the library. I'll see you there, and we're going to do some more regular polygons.